The Outspoken CIBSE Engineer Podcast Finale, Season 3. So the last few episodes, we've discussed various ways on net zero. We've sat down with an inventor. We've sat down with a millionaire plumber. We've sat down with someone in sustainability, Martin Fahy. We sat down with Jeff Curran. He was an energy guy. Now we're sitting down with someone incredibly technical, and he's questioning a lot in the way we're doing things, really, in design, product application, and hopefully a few of his insights will help us tweak and maybe improve in the way we're looking at things. He's incredibly outspoken because he is in a small niche, and it's pretty cool the things that he's doing. Phil Draper, we met him at MITSI, Page 24. He was on stage for... How long were you on stage for?
It was supposed to be 10 minutes, but it went to 13.
You were 13? But you got in so much information so quickly, and I literally nudged Ben. You were the only person there for the day. I was like nudging him, and I was like, Ben, we've got to get this guy on. He knows some stuff that he can help a lot of people with the way he looks at things. It's great to meet you. Phil Draper, 21 Engineering.
Yep.
Great to meet you. Start off, Phil. You're the MG of 21 Engineering. What do you do?
So I always start. So the 21 initially, everyone always asks where that come from. My old door number. All right. So that's for the first one. Generally, one of the first three questions people say. The old door number means something personal to me, as it says.
Okay.
21 Engineering is based around the skills and that I picked up over the years of operating in building services.
Okay.
So I try to emphasise and expand and share the abilities we do. Generally, we sit between the FM and main consultants, the big boys that sit, to actually make things work in between that way.
Okay.
There's a real big skills gap, effectively, from what the FMs can do, understand, between actually what the larger consultancies are really looking at.
Okay.
So we sit in that point there of actually making buildings really work, identify where things really are, and actually then supporting the teams actually from the identification to the operational improvements going forwards.
Fine. Okay. I get that. Okay. So your background. What's your background?
Probably the official term is jack of all trades, master of none.
Is it
going
really?
For that way? Yeah,
really?
yeah. So I'm a trained electrician originally, going back in the early noughties, but doing it actually in a manufacturing place where we dealt with stuff for Class 10 clean rooms, actually doing stuff for NASA. So you've got to really understand how systems work. When you've got to control a room, 20 by 20 meters, and it's got to be plus or minus 5% humidity, you've got to understand how an AHU really works.
Was that understanding from having to reactively fix and repair, maintain, and kind of get the understanding that way when things went wrong?
But the key thing there is you're trying to make sure that you've identified it before it goes wrong, and that's always the key thing, is actually understanding how it's looking at. So, within the 4 years, actually going from my starting actually onto the tools, I then progressed into what they classify as a factory services engineer. Okay. My first job on shift was to check everything was working as it should do.
So it was okay. So,
I'm
preventative, and also
that's always a key
looking
bit.
At exactly.
Understanding. We started moving actually back in the early noughties actually to predictive maintenance in a way actually of checking rather than doing so much. Actually looking and monitoring.
Who was above you, Phil, on that then? So you were accountable to who?
Because
that role you're describing is really important, because if you're not doing your job properly, it's like pulling out the last block in a Jenga tower and it just all tumbles.
The hardest bit I had when I took that role was everyone who I was above in the per se, they were the guys that taught me how to do it all. So it's a very weird one. As much as I was accountable, it was a team effort to get it working. I was just the one that actually just probably looked at it in a different way.
I see.
To try to guide it, actually trying to understand how the technology at that point could work and engage with people sitting there. So the guy on the opposite side of the shift, absolute legend. He'll never watch this because he's a bit old now. A guy called Graham Sharpley. Fantastic guy. He was an old school engineer. Everything. He didn't use his computer much ever that way. So when
was he the keep it simple, stupid kind of guy?
But
don't overcomplicate. Go back to basics. Strip everything back.
He designed a heating system for Tower 42, and actually at that point,
I've worked in that building. The NatWest Tower.
Oh, wow. So he designed a regional heating system going for that way. So actually, he used to go for that. So I used to sit there, points going back with him. It's like, right, Graham. So how does this? You talk for that way, and I go, right, okay. What about if we start using this way instead of that way? Well, how about we look at that technology?
Right,
how we so straight away, I'm questioning with almost a one-to-one mental aspect.
You're
as
that
it sits.
annoying Jack Russell, and he just wants to have an easy life. Like, stop, Phil. Stop.
That's probably actually spot on. Probably actually, yeah.
Really?
Yeah.
So where have you got that from? You grew up with a family of engineers?
My dad's a general builder.
Okay.
But unfortunately he's colourblind, so he couldn't go very far in the 60s.
Yeah.
He progressed into engineering because you can't see the colours from what the cable is that way. You can't do it much sense. But my dad's the sort of guy that if you give him a problem, he can fix it.
Okay.
And my whole family we love maths. As bad as it sounds.
Okay.
And you sort of got that mindset of there's a problem or how you fix it. You straight away it's trying to sort of itch your way and trying to get to where the problem really is.
Okay. You local?
I'm also use the term born and inbred in Braintree, but that's quite bad for the area. Ooh. But I'm only sort of 2 miles down the roads.
So you've not left Braintree since day one?
No.
Seems like a nice part of the world.
It's a centre. There's lots of history. I do love Braintree.
The only thing I will explain,
the traffic.
We went to a petrol station on the way here, just down the road.
Oh yeah.
The guy fills up the car for you.
Yeah, that's my second cousin. That's where the term comes down to. I think maybe third cousin. Yeah.
Couldn't believe it. Pulled up. Guy comes out, thought, well, what's going on?
Yeah, he doesn't open
started
Sundays.
filling up.
Doesn't work Sundays.
I thought it's because he doesn't trust anyone that drives in.
No. Just that way, he's got his regulars, he's got those bits and pieces.
Oh, so it is just a Braintree thing? I've never had that.
I think he's the only one in Braintree that does it. But
okay.
he's like late 60s where it is. He's had that in the family for years
Well,
and years and years.
Oh, I see.
Yeah.
Well, if I had that every day, I probably wouldn't leave Braintree either. You could just put, perfect. What a great...
It's Braintree's got all but nothing what you want. I think that's the right point.
Okay. So where do you so you're into renewables? You have to be. It's your business.
Yeah.
Where do you sit with climate change? Mainly the green side of things. So are you I'm all in 100% green. I'll take my scooter and bicycle to most places. Are you, well, actually I'm 50%. I'm actually seeing what's going on and I'm not going to jump in and make any decisions.
We're full net zero at home. We have been for 2.5 years. So as soon as we moved into the house we're in now, within 6 months we got rid of gas. All gone. Solar panels, batteries.
What do you have at home? Heat pump?
Yeah.
What brand?
I've got 2 brands. I've got one for the office, which is a Dakin, and I've got a Mitzi on the house.
How big's your house? 2 heat pumps at home?
No, so I've got an outbuilding. So part of it is actually when we moved to the house.
So what have you got at home? Dakin Altherma?
Yeah, which is 5 kilowatt unit. Actually, I've got reverse cycles. So we've got a little paddling pool that reverse cycles into provide heating for that as well for a concept design.
Okay.
Then we've got a Mitzi unit with Hive controls on the house.
Nice.
We've got the heat pump so we've been in this building now. We pick up the keys on the 22nd of January. By the end of the year, we'll be net zero here. So
fantastic.
Yeah, and the only reason why the solar panels aren't on yet is because the roof needs replacing. We've got a whole new lighting system in. We have a smart lighting system that will do merchant lighting functions. I'm going to link the light into the heating system. I've got actually CO2 controls. I've got downforce drives. You
practice what you preach.
Yeah. So we'll be here. So
I know you have to, but you actually do.
Yep. So we want everything to be smart as well. So it's beyond net zero. So we're trying to use the smart applications to do our maintenance as well. Nice. So I don't want anything. So actually, I want to look on the website and tell me actually what my tap temperatures are last night. I want actually on my system to tell me what's not working.
Okay.
I want my smart valve. So the reason why that Danfoss valve is sitting there is because actually that's going to control my zones for my heating system. So we actually was price zoning actually this heating system. So I'll pre-warm building and that sort of stuff. I'll control that. Tell me my flow rate. That tell me everything where it sits. That tell me when it's out of life.
Takes a lot of time, that surely. Or
it takes a bit different to design. Trying to get my 72-year-old dad to plumb it in. What takes the hardest bit is it sits. Okay. But obviously, to be slightly more practical is, I had to put some oil in because where we sit, we don't have gas here. I had to put some oil in actually on the 15th of January. Yeah. That's the last delivery we'll make. And that's a promise I've made actually to the employees.
I see.
We'll all get a problem. So I'm not going to turn it off before it's run out. Sure. Because I don't want to give away oil because it doesn't work that way.
You want to burn what you've got.
Yeah, exactly. Yeah.
So first question I've got for you, and this is what a lot of commercial building owners have and a lot of PMs and myself, about does retrofitting in commercial buildings need to be that expensive? The scenario I have for you is I've got a 4-story commercial building. It's currently running on gas. I want to look at coming off gas. We have a chilled circuit as well, so we have a chiller. It's going to be really expensive, right?
It'd be between a 2 to 4 year payback to go for with part of the chiller replacement to get rid of gas.
What, in energy saving?
In additional savings you'll get from get rid of the gas and those bits and pieces.
Okay, so
the first job we done, first heat pump retrofit was for I won't mention the name, but for my previous employer. Yeah. back in 2014. So we're October 14th it was.
2014, right?
Yeah. It was
so this was before net zero really took off.
This is all energy management. So the additional cost to put in a 4-pipe heat pump it paid for itself in 12 months.
It paid for itself in gas savings?
In gas savings, yeah.
Okay.
So that additional expenditure to go from a 2-pipe efficient chiller to a 4-pipe Mitsi unit or Iraq unit for the Clean Veneta brands paid for itself in 12 months.
So you say that to me. Okay, so I've been out to a couple of consultants and they've all suggested a 4-pipe chiller. That means I'm going to get some energy savings, right?
Yep.
Is it as simple as that? Just throwing a design together of 2 4-pipe chillers, and we need 85 degrees, so we're going to have to boost that with a HT unit or something.
So now you start getting the problems straight away. Then it's not so much the temperature, but the first thing is, and actually for the job I've done for my previous employer, my largest client is now, we've done a head office design. So we took all the responsibility to get rid of their gas boilers. So they really stepped into the mark, large rear, going for that way. They went the whole winter without any heating through gas, all heat pump. Biggest problem we had there for retrofit, space, power. Okay. That's what generally makes retrofit for heat pumps. Heat pumps are bigger than chillers.
So you're right. So my commercial building that I've got an issue with power. I don't think we've got enough power to do what maybe suggested.
So we're actually using less power now in the peaks for the cooling than what we would do actually for the winter. So there's no power issues straight away there. And actually we've now got more space in our boiler room. Now we've got rid of the boilers.
Okay. So why? What are you doing differently?
Application. It's all about application, product placement, making sure you've got the right thing, make sure it sits, understand how building works, put what it's got to go for that way, put in additional products, make sure you've got your metering in, make sure you've got the right control valves, the monitoring, preheat, go for that bits and pieces.
So are you suggesting before I do this to my commercial building that you need to come in and meter my building first to actually find out what exactly I need?
The meter will tell you everything you need to know, because it will tell you, especially you start getting ideally more than one winter, exactly what your peak, and you start looking rather than a peak for half an hour, you look at a peak for 2 hours. You look at that way. So what does the real energy need to heat up a building? That allows you to actually dramatically going down. When you start putting that into some advanced modelling as well, it allows you actually to sense check it. So you've got 2 means. So for this large rear that we deal with, we look at it from 2 angles when we come to retrofit. Yep. We look at the half-hourly profile, 15-minute profile for the energy data, and we look at the profile actually for the modelling system. Okay. That makes sure then that both are correct. So we can straight away walk away with full reassurances that it's working in that right way.
Okay. So you'll meet it before. I've got hot water that I need, domestic hot water. Is everything like for like?
So domestic water and heating systems are not the same. Okay. They can't be the same. So you've always got to make sure with a retrofit.
So if I've got 2 90 kilowatt gas fired water heaters, do you approach that with we need 2 90 kilowatt heat pumps?
Of course. Again, that's a whole aspect of understanding how buildings really work.
Okay.
The peak loads rules of thumbs are way out of date. Okay. They're dramatically they're 20 years because they didn't have the knowledge that they've got now with metering data to review it and make sure the real applications are there as it sits.
I see.
And especially when you start looking at smart hot water cylinders and that sort of stuff as well, it makes it so much easier to actually have dual source working, going for that way, and more storage and heat recovery and those bits and pieces.
Okay. So what type of modelling out there? Because are there new modelling tools that are available?
Have you heard of Neighbours, not the TV programme?
No.
So Neighbours is the National Australian Benchmarking Scheme basis. So the Neighbours,
I've heard of these. I've heard of these, actually. I think I've heard them by watching one of your seminars. Possibly. You've mentioned it.
Yeah.
So Australians probably mean it's been... we can use the assumption that they've been there and they've done that. And what I mean by that is they're there before us because they're big on heat pumps.
No, it's not so much that. Australians are big on energy management, big on climate, going for that way. So they are... the Neighbours scheme came out 15, 20 years ago. So really modelling buildings properly to understand how it should operate. They've got their star ratings going for that way. That got introduced in the UK sort of 3 years ago. Had a bit of a hiccup recently because the previous certification body decided to not support it anymore. CIBSE now picked that up as well, so it's going to be back on the line then.
I see.
But that modelling you do for a Neighbours building,
Yeah.
either from the existing one actually for the design, is so much more accurate because it uses so much more information to give you a real life scenario at work, and you can start looking more around the profile, how the energy is being used into it, not just peak loads, which you actually get out.
So you're actually using the data that's now available, then maybe assumption or calculations which are open to many, changes with temperatures and usage and people.
If you go to model a building, and retrofit's probably a key way you think about it, and you actually put in the electrical profile for the lights and power onto it, that's going to be far more accurate understanding a cooling or heating profile when it is to go around. Yes, you've always got the concern actually over lease changes and those bits and pieces, but there's not many buildings now that are going up in on-floor energy because the need for lights energy is going down. Which actually is the way when was the last time you saw a CRT actually on a desk? Yeah, when was the last time even a printer, bits and pieces? You've now got an LED screen. You've now got a laptop,
which consumes a lot less. You're right. So your peak loads are a lot lower.
And then you start even looking at what you can start applying to ratios actually for occupancy. When was the last time you even saw a floor plate fall? You start applying some actually.
So what it was to versus what it's like.
Yep.
So potentially we have got enough power. It's a case of,
without a doubt,
because what seems to be the norm is you'd open up an LV switch panel and you'd go, it's got 100 amp incoming and there's 140 amps in there. Oh, we can't add any more into this, and then it's written off. But what you're suggesting is, well, once upon a time, them 32 amp supplies were actually utilised at near 32 amps, whereas now you probably find it's a quarter of that, if not that.
Yeah, exactly.
So you need to use metering and the data to then go in the overall picture of, and that's when you turn around and make a comment saying, well, I think you have got enough power. I just don't think you understand
the easiest thing to look at now from the top line for this building you'll talk about, it will have a half-hourly meter. So you get that, and you look at the profile, and you work
do that
out,
over 2 to 3 weeks or 4 weeks, and straight away
I could probably get within 48 hours, I could get that metering data going back 2 years.
Wow.
So I can look at the hottest day. What was it doing then? Going for that way. Look actually what your chiller's using versus what the 4-pipe would use in terms of actually the peak load capacities, and then go from there.
Okay. So my building that I've got a certain amount of cooling and a certain amount of heating. I would then go out to a consultant probably, and the consultant would give me a design. They would go out to tender the work, and then I'd get the work done. Is that solution with net zero not the right solution? What are consultants as abroad these days? Are they relying on the manufacturers for the information? Are they then saying, well, we've got I had a 500 kilowatt chiller on my site. Are they saying, well, let's go to 3 chiller manufacturers. Let's get the price for 3 chillers and the spec, and then we look at the COP, which coefficient performance, the seasonal efficiency rating,
Ratio,
and energy efficiency ratio.
Yeah.
And then I would, as an engineer, go, well, the COP on that chiller is 3.5. The others are 3.1. I'm going for the 3.5. That gets put into the spec, and then it would go out and be installed. Is that the wrong approach to coming off gas?
If you go back to the car analogy, and if you looked at a car straight on its MPG, but how a salesman would select a car and its MPG will be different actually how a person going around town would select it. Because you'll start looking actually what you want the car to do for its main workloads. So you select your efficiency ratio, MPG, in a car scenario, based on your average usage, not actually on what it can do. So a BMW actually is probably more efficient for a long drive than actually what it would do driving around town.
Okay.
You start looking actually then a micro or something small around town is more efficient than what it is actually in the BMW, but worse in the other way. So you start looking actually at the true application of how it should be worked. And I know the UK is getting warmer, but most of the hours really for the cooling system is actually on a part load basis. So when should you be looking to select your unit? Do you want it efficiently when it's not being used, or do you want it efficiently actually that peak time period for those 4 weeks across summer? Which one makes more sense to be more efficient?
Of course, the part load.
Yes.
So you would select an item based on its efficiency at a part load?
On the run hours, eventually.
I see. And most chillers, depending on the type of compressor, they seem to be more efficient at the box at
Well, most of the
at
design
at the lower loads or the higher loads.
the
right?
higher loads, obviously, that's what they're designed for.
So if
So
you
start
select
looking at it.
so if you select a 500 kilowatt chiller, if you select a 500 kilowatt chiller and it has a really good high load efficiency rating.
But it might be poor at low lows. So actually, where do you get your money back from?
So would you, in that instance, again, not holding you to it, would you then say, well, you may want to look at a bigger chiller or possibly a smaller chiller that is more
modular?
More modular.
Yeah. So the modular might come back down to one of two ways. It could be modular in a flow rate, or it could be actually modular in selection. How it works. So trying to get the efficiency out of it.
Okay.
So when you can start actually applying, so the weird bit when you start looking at cooling systems, people start forgetting actually what the calculation is for it. So energy in water, delta T, flow rate gives you your energy ratio.
Yeah.
You always want to try and work backwards. So the delta T is what generally derives the efficiency for the system.
Mm-hmm.
If you try and keep that the same, one thing's got to change. The energy in water ratio, it's going to be the flow rate.
Okay.
So you've got to try and look at how it could work. And in retrofit, it's always not that easy. You might start trying applications around bits and pieces.
Yeah, okay.
But you start actually getting a product selection that can adjust the hydraulic systems. So you start looking at the whole energy system rather than actually just a chiller. That's actually what people sort of forget is they look at the chiller, they don't look at the whole system performance.
Okay. An immediate question that comes to my mind because we get involved with these replacements is how does the chiller talk to the pumps? Because we tend to be involved with BMS, and the BMS usually my pump engineers, one of them in general, if he was here, he would say the issue is with most commercial buildings, we put really expensive IE5 variable speed pumps.
Yep.
And we use them as fixed speed. And the amount of sites that we get involved with and they get involved with where they put these lovely efficient pumps in and they're not controlled properly.
That comes down to the selection of the unit. If you've got for a chiller that can't do variable volume, that's what you've got to go from.
But in regards to if you use a chiller which does do variable volume, is the conversation between the pump and chiller done from the chiller? Or is it done from a BMS system?
No. The BMS system would do
the
it.
BMS needs...
Well, quite product. Actually, that's really quite... You put in one of these, and you put in one of them.
And what's this?
That's a heat meter, thermometer. So obviously that's a smart one.
This is a smart heat meter.
So you say smart, it's the fact of how you read it. This actually could tell me when you start looking at product selection, what the flow rate is, what the delta T is. So I can start actually regulating the system to suit the efficiency from what data it gives me.
Ah, interesting.
So that will actually
determine... Is that something that has to be manually done, or is that something that a BMS system could look at?
system could do it.
Could look at it and make the adjustments?
Yeah, and that's actually what you go from. So we put in... I product selected a 250mm one of these. Absolutely humongous.
250 mils, so that's what, 12 inch?
Yeah,
25.46.
Yeah, 14 inch.
Yeah.
It wasn't cheap. It paid for itself in 6 months.
What is it? Is that just an actuator?
That's a smart actuator.
So that's a commission set, isn't it? So
It's
that's
a pick valve. That there at the bottom is a pick valve. That's in a smart actuator, the Novacon actuator on the top. Yeah. So
that can go outside. Looking at that.
No, you have to put a bag over the top.
You do have to bag it.
It's only a bag. Okay. But that tells you where the stem position is. So straight away now I can control it. There's no arms and R's, so that controls to 0.1 of a millimetre for the position. That will feed back to the system, so I can make sure that all the loop works. So I can adjust the flow rate with that.
So for those that will know what that is, or you've just explained what it is, the BMS system will need to control that. Is the chiller smart enough to tell?
Why does it matter? The chiller's not. You haven't got to make the chiller smart.
When you mentioned the delta T, so if we're trying to,
but that tell you what the delta T is.
Okay, so we're actually not using the chillers. We're using our own device to tell us the delta T and make the adjustments.
Yeah, because when you start going for 2 chillers and you've got 2 systems running, you want to have a common one. So if you look at a primary system and actually under heat network regulations, over bits and pieces, part L, you've got to have metering in the right place.
I see.
So you put a heat meter on the primary circuit, it'll tell you what your delta T is, it'll tell you what the flow rate is, it'll tell you what your energy ratio is going for it. Helps actually with your COPs going for that way as well. I can adjust the flow rate then to maximize the performance.
This system here then, or this setup, this is something which I kind of want to say could actually be retrofitted in afterwards.
Of course it can, yeah.
So you could look at it from day one, which is perfect because or you could say, well, actually, let's get everything running more efficiently. Let's retrofit this in.
But it's more expensive to retrofit. You've got to start cutting in a valve, flanges, those bits and pieces actually without it. It's not cheap as it sits. putting in that is not much more expensive to retrofit.
You say that, but then if you're looking at, if I had several buildings, the payback would be significant, surely.
It would do. Yeah. So we done a job, a large commercial building, 30,000 square metre building.
Mm-hmm.
Yeah. It was using 120 kilowatts in hydraulic energy going for that way. The chiller energy, it was a York unit, really, really efficient, reasonable good turn down, but all the energy used into the system was all hydraulics.
I see.
So when you start trying to put in something like this way, where it sits, that's where it sits. The hydraulic savings is what you get more out of a system.
I see.
What you would actually do with almost with a chiller selection, but the chiller selection's got to allow variation in the hydraulic flow.
I'm with you. Okay.
So the key thing what you always got to do is understand what the chill requirements are for the flow rates, what the change ratios, what's the min, what's the maxes. Make sure they don't have any issues. The rate of change is what's quite key with where it sits.
Okay.
So when you start understanding how that can work, these things pay for themselves in months.
I'm with you. Well, it's enhanced control, isn't it? It really, it come into you enhance control the way it works, and then you get efficiency. Rather than just swapping a box over with a new box and having it run the way it's always run.
Yep.
So my building with a 500 kilowatt chiller and 500 kilowatts worth of heating through gas has got 2 chillers and 6 boilers. And what I mean by that is I've got 100% redundancy. So when you specify, changing things to look at the peak loads, etc., do you like having 100% redundancy on site? Or are you more of a, well, actually, Jacob, you're better off having 50% redundancy on site and having it all running at 20-30%?
But where do you see the risk in redundancy? Because actually you start looking at single point of failures. And that's what the problem. When you've got a 2 compressor...
So if I had a 2-circuit chiller, 4-pipe, and then I had a single HT, and then I had that times 2. So, so if I lost a whole chiller...
Okay, so
whole HT unit...
But you look at the HT, and what's it there for? How long is it for? So depending on the design ratio, is if you've got designs in one way, you will need to have 2. If you design another way, the worst thing you might have is actually... on the really cold day, it might take a bit longer to heat up the building, or you might have to start shutting down another plant. But is it worthwhile putting in a second one for that side? Comes down to the client.
If we've got the space and client requirements, and they're nervous of losing chillers and element, would you prefer? So if we are looking at a 4-pipe chiller with a HT unit to go up to 60 to 85 degrees, depending on the plant on site, and then having that times 2, so we've got 100% redundancy across the whole site. Put into one side the size that's required on site. Would you say it's better to have one system running and then duty standby to have them rotate? Or would you say, well, actually, if you size them both correctly, have them running together?
The issue when you start looking at operational times...
Because it's an old way of doing things where you have, 100% diversity on duty standby. So if something goes wrong, you have a catastrophic failure, to have a 100% fail-safe on site. Is it really needed?
I think with the risk leases, and you start looking at beyond equipment selection, and you look at how much it might cost a landlord to not have the building operational because you haven't got something, that could cost a lot of money.
Okay.
And that's almost where the risk comes down to, that drives that side, is actually what's the financial risk to the landlord by having an operational building?
Fine.
What's the response time? That's the bigger picture to look at. It doesn't actually come down to the consultant to come for that way.
Okay.
That's understanding risk, financial risk for operation rather than...
So one of the questions that needs to be asked at the start with the stage 1 is, what is the risk of having...
What's the requirements?
Right, okay. And then 4-pipe versus normal heat pump. So, this building I've got, someone's thrown me a heat pump chiller at me, which looks more efficient than a 4-pipe, because the 4-pipe heat recovery isn't, is efficient, but correct me if I'm wrong, a 4-pipe chiller in heat pump mode isn't anywhere near as efficient as a heat pump chiller. So why don't I have a chiller and some heat pumps? Am I doing myself out of 40 to 45 not having a 4-pipe, or is it a valid point?
So obviously most 4-pipes now will do up to 65 at -5 still. So in terms of obviously the product selection in terms of temperature, that's gone out of the way. In the UK, we generally...
Sorry, so there are 4-pipe chillers out there which go up to 65 degrees?
Yeah.
So that's getting the right selection.
Yes.
Right, okay. There's only a few of them products out there.
Yeah,
Most full pipes are sold as 40, 45.
yeah, but if you actually ask the manufacturers, will it do that way? It will do, quite happily.
Interesting.
Yeah, that comes actually down to what you're asking.
This isn't like adding like a super chip to an ECU in a car.
No,
it's actually something that's available.
Yeah, off the shelf. Most manufacturers.
They'll go to 65 if you ask them.
Yeah. But I think most of them they're getting up to 65 with a few of them, but most of them will quite happily now sit at 60 at -5.
Interesting. So the HT units are actually going from 60 to.
But again, 80 is well. You don't need 80 degrees in most buildings.
Okay.
And if you do need 80, that's only for 25 hours of the year. So why design a heating system for 25 hours?
So I'm going to say to you now that my gas boiler in my building is set to 85 degrees.
It's wrong.
And I've got 80. I've got radiators which have 70 odd degrees being pumped through them. They're cast iron. It's an older building. If you put your heat pump in and it does me 65, 70, surely them radiators aren't going to be efficient.
Why is that?
Because they're not designed they're designed for 70 degrees.
They are designed for 70, but what's the objective of a radiator? Is it designed to give you 70 degrees? Will it still heat up a building at 60 degrees? Yes. So the worst case scenario...
But the radiator's not going to be as hot.
Why does that matter? But again, you can't touch a radiator at 70 degrees anyway. So a lot of the key thing when you start looking at retrofitting that sort of point, it's a cultural change as well. Yeah. So without the cultural change, you're not going to get the product change. So generally...
So just to answer for me personally, because the reason I'm saying it like this is because some people, until they know there's a glowing hot radiator in the room, it's not working. They're used to feeling it and going, oh, it's hot, it's working. Whereas I would agree, I don't feel like you need 70, 80 degrees going for a radiator. But technically, because we know a lot of people that ask these questions, I'm one of them. So if you have a rad and it's... Ben touches the radiator, just people can't see. It's probably running at 70 degrees or 65. So having a rad running at a lower temp, you're not necessarily going to... Because if a radiator is specified for 1.5 kilowatts at 80 degrees or 75, you're losing efficiency, aren't you, putting less temp in there?
No, you're not losing efficiency, you're losing output.
Okay, you're losing output.
Yeah,
so the output drops?
Yep, marginally.
So it's not a significant...
It could go up to 20% if you went down to a low temperature.
Okay.
But if you've got 70 versus 80, you're not talking a great deal of difference as it sits.
Okay.
So,
but the cost difference between going from 65 for a radiator to 75 in terms of money is...
No, the cost of it is going for a heat pump that can do 70 to 80.
Yeah.
All of a sudden, then everything's been oversized dramatically. So for here, we've got actually for a Viessmann unit that will give us 70, R290 unit... I'm not swapping out any of the rads because I know 70 degrees is going to cope the whole point.
Okay.
So that's what you got to sit at. The worst case scenario, I might have to turn it on half an hour earlier. So I put my money investment, rather than changing out all the rads, into monitoring to make sure the fact that actually I'll never let the building get cold.
I see. So you're actually changing the way it's running.
Yes.
And then for layman's terms, something that I would like to know. So if my heat pump downstairs or my full pipe that's been suggested to go into my building is delivering 65, 70 degrees. Does that mean I've got 65, 70 degrees on my fourth floor? Or does it not? Does it mean I need to go...
You're always going to get a slight drop. But again, look at actually what the building needs to do and how it operates. You get so much more investment by upfront looking, reviewing and operating and proving you don't need it and getting everything working. So one of the key things we've done for this head office, we actually got all the fan coils investigated and found problems that we've now resolved.
I see.
That's what's now made the improvement and basically made the heat pump work because we've got a system working first.
Goes back to you put 80 degrees for a fan coil, you say, wow, that's really high. Why? And then you say, well, if you drop the temperature, watch it, it'll stop working. And the reason is because it's the secondary circuit needs a clean.
Yeah,
or strainers are blocked, or filters are blocked, or you've got one fan deck running. So this sort of information is critical before we even look at a stage one design.
The telltale sign is this time of year is quite key. So obviously Friday we had 21 degrees. If you've still got to have a heating system running in a building at that temperature, you've got issues. Okay. If you've got a cooling system running today at 8 or 9 degrees, you've got issues.
Yeah.
Anyone that's looking at a replacement of a heating or cooling system that's seen that's where you start first. You don't start looking at a chiller replacement. You sort out the problems you've got to fix first.
Okay.
And that'd be something basic.
Okay.
Probably poor maintenance.
I'm with you. Okay. We've mentioned radiators. Air handling unit. So my building's got a couple of AHUs in and they were designed and there's a badge on the side that says 612 cooling and 80, 70 heating. Does that mean that I need to have a heat pump that gives me 80 degrees? I know it changes the design, but is there an option to go in at a lower temp and adjust things?
So it's a very silly question. What is an AHU?
Officially, it's an air handling unit, or the technical term is it's a box with a fan or two fans.
But what's it supposed to be doing?
It's to bring in tempered air, or depends on the spec. If it's designed to bring in tempered air, or it's designed to bring in heating or cooling into a room.
Right, no. So you missed the crucial word. What is it there for? Why do we put AHUs in? So in a commercial building, you've got fan calls and AHUs.
It's usually these days it's to bring in a minimum fresh air.
Thank you. Right. At
Content.
7 o'clock in the morning when it starts, do you have the same occupancy at 7 o'clock in the morning as what you do at 11 o'clock in the morning?
Of course not.
So do you need
in the morning you have less occupancy, but you may need the additional heat if it hasn't been running overnight.
No, that's what the fan calls are there for, or the radiators are there for.
Okay, but if there's no fan calls in the room, and we're using the AHUs,
that's a VAV system, then, isn't it? Well,
correct.
Yeah.
Correct.
So again, you can recirculate the fresh air. You'll recirculate the air round. As long as you're monitoring the space, and again, COVID's brought some good or bad situations down, but it's now told us what is a good fresh air level. So you can control the space to 800 parts per million, and you've got enough sensors around to monitor that, and you're recirculating air and it's still doing less than 800. Is your air clean? Well,
it's really interesting you say that about research, because old AHU systems were direct supply, direct extract, whereas now...
it depends on the age. It was a real point actually in the late 80s, 90s, where you actually had separation of the systems going for that way.
And then it went sort of... it was more thermal. You had a bit
of research and you bit of thermal will, but there was a bit of a selection, so they did got rid of, because it didn't matter about efficiency because the cost of energy was low.
Correct.
But why can't you actually still put a research system in? So
now you put in a research system in to replace. My building might need a replacement AHU. If we put a replace,
again, you haven't got to even look at it's ductwork changes. A lot of things that happen, people overlook what's got to be done. And they look beyond the simplicity aspect of how things work. So you've got to have a whole AHU replacement to get some research going in.
Right, okay.
So you don't have to change things. You haven't got to look at everything.
I know where your angle is, because you're right. You can adjust things with dampers and insert research. Yeah. I completely get that.
So why look beyond?
So but if I was to have a more older setup without research, and then you were to say, well, Jacob, you could put 65 degree through this heating coil. There's nothing wrong with that. You're putting a new AHU in, which has got research. Research is doing you a massive favour.
Exactly. So but the duty comes down as well. How you work it, everything works. You've got to look at everything to what the basic needs are.
And if I was a consultant, I would probably say, maybe the norm is, well, this is the size of your box you've got at the moment. We need to replace it with a similar size box with research. So,
which would generally make it bigger.
You would generally make it bigger.
Yeah, a research system generally. Or most
I know with a thermal wheel, they're...
Well, also you've got to start looking at the specific fan power. That's obviously changed. So generally AHU boxes are now getting bigger as a replacement. So again, do you need to replace it? Can you change out the fans? Can you do anything else? Can you add retrofit in research? Unless the fan box is rotten, don't replace it.
Right. So these questions that you're sort of asking before you just make these general assumptions, just replace everything, is I kind of say is your kind of niche, because
understanding buildings.
It's understanding buildings.
That's
and it's actually asking the questions. Well, why do we, rather than just say rip my gas boiler out, replace it with the same size heat pump because the thermal model tells me we need this much. You now actually, if you want to nail this net zero efficiently, so you need to understand the building and the occupancy and how things are actually working.
The first thing you got to understand is what is the client's requirements. What is their long-term objectives? That helps you actually to make the right adjustments in the plan going through as it all works. And you start understanding other things like service charges and risk compliance and asset replacement programs and those bits and pieces. You start working with clients to get the whole pathway understood for the next 7 to 10 years.
I see.
That's what makes us a bit different, is we work with our clients to get where they want to be in an efficient way. We might make savings. We'll look at metering. We'll look at their life cycle. We might look at fan replacement. All gets to the right pathway actually over.
And before you get to that, and once you have that information, if you're looking at replacement projects or a project where you want to do net zero, you can pick up that information and say, well, this is what we need. Or this is what you need to go net zero because we have the data. We're actually going to use less on site because you don't need it anymore.
Yeah, quicker.
The building's changed. You've got less people working in here. etc., etc. There's obviously a lot of variables because before speaking to you today, one of the first things that I always look at, and I think a lot of engineers and consultants, and we've all been led down this path, is, well, if the COP isn't over 3, it's no point doing it because electricity is worth 3 times the amount. But what you're saying is, well, our units will give COP, but you need to understand that you can consume less because you're consuming too much in the first place.
But you're looking at the COP of one piece of equipment. You're not looking at the COP of the system. That's what you've got to start looking at, is looking at the overall system performance. If you've got a pump that's running flat line the whole time, your biggest saving could be putting in a new control valve rather than what it is actually doing anything else.
It's like, I suppose it's like it's like buying a really, I'm not going to use Tesla, I'm going to use a really high efficient
Other
diesel.
brands are available.
Yeah. A high efficient petrol car with an MPG of 50, but then driving it like an absolute weapon.
Yeah.
Because you're looking at the car, but you're not looking at who's driving it.
Well, again, as I said to you before, a BMW driving around the town doing 20 miles an hour is less efficient, but it's more efficient actually
on a long run.
Exactly. So you all around product selection, placement, operational
But there
controls.
seems to be a massive thing with this, with net zero and heat pumps and chillers, that and maybe manufacturers are partly to blame for this, and that is the information they give us. If I get a product selection on a product, they all give the same information, and it's almost as if, unless you know what you're asking, COP
exactly.
and ER figures are the solution.
The nail you hit straight in the head. If you're asking the same question, you're going to get the same answer. If you are asking the right question, or change it around slightly, or ask them a shorter question to give them an opportunity to actually tell them what they can do, what they can offer. Okay. And sometimes you've got to adjust your design once you've got a product that's more suitable. You start asking for 4-pipe 65, you're going to get the same one. So deviation. You start asking, right, this is my requirement. I need this peak loads. I've got this type of system. What can you offer? What can you go from? So this job we're doing at the moment, we're actually converting a condensed system to an ambient loop. We actually had all 3 large manufacturers come in. We've now changed our design, probably our 3rd design change based on what each one gives us, because actually we've now got such a better selection. High temperature, more heat recovery, less space over bits and pieces. But compared to one of the other manufacturers, they offer something different, go for that way. So you've got to, again, if you go to a Ford sales room, and ask for a BMW spec, he's not going to give you a BMW.
Yeah, for sure.
So, but if you actually went there and say, basically, what I need is a car that can go on long journeys, that's got this amount of boot space, over bits and pieces.
Yeah, of course.
Then you start looking at, you ask the simple questions.
So the manufacturers then, so if you are asking the right questions, they tend to have the answers.
Yes.
And if they don't, as yourself, you would say, well, we're not going to use them because they can't give us the answers that we need.
So
and you would value the because as an engineering, on the engineering side, as in being a contractor, customer relationship is massive. Okay, customer relationship is massive. The product is very important, but the top manufacturers, or what we class as top manufacturers, I know don't necessarily have the best products in all elements. They have weaknesses.
Yep.
But I would put that weaker product in because of that relationship. Not to say that we always give customers products, because we don't sell people to products. We tend to give as much range as we can. But when you're allocating, if you speak to 5 manufacturers, whether or not you've got a good customer relation with them is irrelevant. You're after the data. You're after the product which suits that building
reliability,
best.
costs, embodied carbon, all those other questions you've got to ask as it goes that way. And that's actually what is quite key when it comes down to going from it. We also don't try and fit one manufacturer into a job. So we actually might put in 2 brands to actually get the right solution.
Really?
Why not?
I suppose if you're using a backnet or a Modbus interface to control, it doesn't matter what you put in.
Exactly,
it's just a box with a sticker.
And after the warranties,
which you can peel off, by the way. They're quite easy to peel off and just stick anything else on.
The only additional cost is the warranty maintenance period.
Well, the challenge is with most chillers and full pipe heat pumps, you only get a 1-year warranty anyway, unless you want to pay for the 3 to 5%. So,
but after the 1 year, it does, as long as you're maintaining it to their standards, the warranty is still covered. Yeah, so you can actually go and get a gold partner.
That's really interesting you say that. So, because it's so out the box. As in to say, well, I've got a full pipe chiller, which is one brand, and then we use a different brand as the HT unit. I know you probably wouldn't, but you could.
Well, I don't understand. Why is that out of the box? Why is that? It's as simple, isn't it?
It's kind of like, as a contractor, it's real, like, you never do that. you would never mix brands on site. If anything, it's massive blasphemy. Like you never would.
Yeah, I know, but why? What's better for the customer?
I think it's like that that question, as in why do we do things the way we do things? And it's
because it's always been done. Because it's easy.
Yeah.
But it's not easy for you want to get the right solution.
If you're doing it for the customer and you want to do it for the right solution, you're going to do what you got to do, right?
So what makes me different is that I've been a customer. I worked 7 years actually as a.
So you as the other side, you've seen what the what contractors say and consultants say and the manufacturers say. So you know the way things work.
Yes, I understand all the terminologies from the guy installing it on the ground to actually the person selling it. They haven't done the sales party through my time of metering. I've then been a client, understood how to operate it, to maintain it, what I'm going to procure over bits and pieces. I was an internal consultant, now my own consultant, and understanding the whole means of the whole life story as it sits. So one of the key things actually that I try and do as well for my large clients is I'll take them to the factories. So they'll start hearing from the horse's mouth what's good or bad about the product. It also makes it easier. So, this Novacore valve, you can get cheaper PIC valves, of course you can do. But this now goes into most of the job projects I've got because the client sees the benefit of it.
Yeah, of course.
So in terms of that value engineering, value doesn't mean cheaper. If not, it'd be called cheaper engineering or money-saving engineering.
Yeah, of course.
Value can be spending more money on one section to get less on another.
For sure.
And that's what sort of people don't.
So before we sat down, you mentioned about, yes, it might be more expensive to have in one side of the building, but that expense on one side will actually make a saving elsewhere.
Yeah. So again, this valve, this is a key one here. Put one of these in, your commissioning time and cost goes down dramatically. So that comes down, that's a procurement issue. Okay. The issue at the moment you've got with procurement of these units is the fact that you don't get any savings as it sits down for that way.
I see. So are there any products that you really, really like? Like, again, I've got no affiliation to anyone, but like packaged chillers, I love the E-Series. Dean Flint, ex-president, said you could drive a bus into it and it wouldn't break. It's VRF technology, it's super efficient, similar to Turbo Core, and it's pretty cheap, and it's almost off the shelf. So that's a little niche that I look at, and I'm like, well, if we have a chiller replacement, straight away, perfect. Brilliant product. Dakin have just brought out a modular dryer cooler condenserless product, which I think may tip that. Is there anything you've come across in several products where you say, well, I know you may say, well, it depends on the building, but
that's
stop.
Really? Yeah, I would never say this one's better than that one because you can't do that.
You're like the manufacturers, like the sales reps must like really detest you sometimes because they want to make the sale, whereas you're saying, well, I don't care. I'm going for the product.
On the opposite point, we're generally the ones they come to first because we actually understand that application. So we can't start looking at actually what their new products can do. We're the guys that work out how it can fit. So actually, we are love to be hated.
Yeah,
because they might not always get as many sales. Great place to be. They've got someone that's willing to actually approach new technology and go, actually, how can it work?
So what's really interesting is, so these two products, obviously I know it's slightly different because on a bigger scale, a chiller and a four-pipe, it's just a part of the system. But surely the chiller factories could probably implement more of these controls, or not necessarily. What you're saying, it kind of rings a bell to say, well, actually, maybe chillers should potentially look at being designed slightly different so they are more efficient at part load.
The hardest bit you get then is actually the application it's going into. The chiller or heat pump itself is only a very small part of how everything else work. You start actually getting the chiller to operate in a variable flow rate as standards, and the building doesn't, there's a problem.
I see.
So that's almost what it comes down to. You've got to look at how you look at the whole heating or cooling system and actually apply everything then. So it might mean you actually, to get the right chiller in, you've got to change out the control valves throughout the building, on the AHUs, onto the fangles, onto the systems as it goes that way to allow you to go for that scenario.
I see.
So you haven't always got to go down to the fan core. You can put actually onto the riser branch, open and pieces to get what you need to convert it into a constant pressure system rather than constant volume to get the efficiencies out of the systems.
I see. Refrigerant? Are you we'll put the product in with the lowest GWP, or you well, this has got slightly higher GWP, but the efficiency is there?
So this thing comes down to the embodied carbon and the lifetime carbon, the sort of TM65 aspect.
Yes.
That's what's more crucial, is actually if one can give us a larger saving. So this
So would you put in a slightly less efficient chiller with a lower GWP number?
So this head office we actually put in, I think it's 513A actually onto the heat pumps going for that way.
Yeah.
Then the lift unit's 134A,
Yes.
which is really, really bad. However, that 5 kilograms saved us, I don't know how much in embodied carbon, in pipe work, in buffer vessels, plate heat exchange, or ultimately sorting out all the fan coils.
So embodied carbon wise, it's a lot less, and on ESG scope 3, it's a lot less because you're not having all these trucks and factories making heat exchangers because I see. So you will go for a lower GWP product, but you are still looking at the bigger picture.
It's application is first, and you work down from what the application is and how good can you get it. And
So you are still looking at the oversight, because I think there still seems to be a big thing with refrigerants. The one that seems to be the future, which I keep getting knocked on, is R290.
Which is the heat pump we've got here is R290. We're going to be putting that
But speaking to people technical with some of the manufacturers, R290 is less efficient than R32. So if you look at the efficiencies, they're not
but
as
then
good.
if you've got so here, if I went for an R32 unit, I'd have to put a bigger unit in, or I've got to change out my radiators.
And then it goes over the bigger picture that the R290 might be less efficient, but
it's less efficient at 70 degrees. I know I don't need 70 degrees most of the time. So you probably start talking actually at the 45, 50, where it's been running most of the time because I modulate the temperature and then weather condensation and Actually, there's not much in it. However, that ability to get an extra 10 degrees, so I can go for a smaller unit and not swap out my radiators.
No.
Which one would you go for?
For sure.
That's what it comes down to.
But R290 isn't big in the commercial space, but there's a few products out there. I'm sure you've come across them because you seem quite well informed with selections. I've only come across one up to 210 kilowatt. I think it's probably more because the amount of content of R290 being a propane. But I think that seems to be the rush at the moment. A lot of it seems to be going that way. What's your view on CO2?
I've done a few CO2 jobs.
Because it's a product, I'm not going to mention them, but begins with C and then it's engineering. It's a British company.
Yeah.
And they do CO2. We stumbled across them for a project we're looking at. And the only thing that I'm aware of is Dakin had a CO2 VRV back in early 2000s. Good bit of kit, but the Delta T's are quite crazy.
Yeah,
and we looked
50 degrees Delta T.
And we looked at the full pipe on CO2, this British company, and the challenge that we had, and also just the standard, because I think they do 80 degrees at the box as a heat pump chiller. But the issue was you had to have radiators which were like, I think they were like 50-10 or...
So
or like,
I know the company you're talking about. I've been to the factory. I've taken one of my clients up there as well to have a look, understand it. The application you got there, it's domestic water is the only real application for it.
Really?
That's really, in a practical side, that's the only place I would ever put CO2 in. It's a CO2 application for domestic water.
And is that because of the drop-offs?
The Delta T.
The Delta T. So do you think that CO2 for the future is probably not going to work?
No. You might be able to put one in actually rather than a lift unit with some right plate heat exchangers going for that way, but still trying to get a 50 degree Delta T on a return temperature that's not there.
Yeah.
You've got to have a return temperature from the building at 40 degrees to still give you that, a 40 degree Delta T, which is, the efficiency's dropping off.
What about, again, I don't know who would make this product, but is there a chemical you could put into the water to change things, or there isn't really anything?
I've not seen anything on the
bit like what glycol does, I know
that's on the cooling side. I know they're looking at products that allow like a phase change material, but that's holding the energy in, not going for anything else that way. That avoids then almost a need to actually a more efficient buffer vessel going for that way. So that allows you to put a smaller heat pump in because you can store it more efficiently rather than actually into a large.
So is it? Would you say, you just mentioned buffer vessels? Let's touch on that. So thermal stores and buffer vessels. Is it lazy consulting and lazy design to just strap on a great big buffer or thermal store onto a heat pump system?
The buffer vessels stores are all predominantly driven by the manufacturer's requirements to have in the primary system a minimum water volume.
This is what we have, yes.
Yep. However,
we've come across it.
You start looking at a building's water volume, it'll probably exceed it anyway. So what do you need it there? So if it says
sorry. So are you saying that when the manufacturer says we have to have a minimum water volume, they're not even taking into account that you've got a building on the end of the chiller?
Correct.
Oh wow, really?
Yeah.
So why doesn't the manufacturers tell us this?
Well, all they tell you is it's got a minimum water volume. That's all they're saying.
Wow.
So that's what they say.
Wow.
So
Well, you say that, but we get led by consultants to say, well, we need a minimum water volume.
because that's what they've read.
But let's keep ourselves safe by putting a 750 or a 1500 litre cylinder on the end of it. And then we know that we can guarantee that chiller will work and it won't have too much turn down.
But that's part of the reason you've got defrost fear and those bits of pieces. That's part of the reason why they put them in. We're now on project number 4, retrofit. No buffer vessels.
So you don't like primary vessel, as in just a single primary in and out vessel for a...
No, we've got no primary vessels at all. The only one we've done it is we had to put them in because there was a delay in delivery for the heat pump. We actually put electric elements into it.
Really?
That's the only reason they've gone in. Apart from that, it wouldn't have gone in.
Wow.
So again, we've got this building been operating for 10 years. We don't have any issues actually on a cold day of defrost. It defrosts, yes, but to actually allow the system to cool down that much during the 10-15-minute defrost cycle, okay.
So I'm going to pick your brain with this now. So, because I've seen drawings from manufacturers quite recently on this, because it seems to be the basic, and it probably goes back to minimum and maximum litres per second and things on the chillers. So if I've got a 4-pipe chiller and I'm going to feed a HT, so a high temperature unit, everyone puts a buffer in between, and then
not everyone.
Sorry, a thermal...
No, not everyone.
Most people put a thermal store in between to say, well, we're going to guarantee that 4-pipe will be able to supply the HT unit with a certain thermal store amount. And then what we're going to do is we're going to put a 3,000 litre there. And then after the HT, we're going to put a 4,000 litre.
Okay, but you've already missed something out there that you've already had to install. The plate heat exchanger.
Well, you'd use a secondary buffer.
Generally, most people will put a plate heat exchanger, get the hydraulic separation as it sits.
So you'd have your 4-pipe chiller, which would then feed a second 4-pipe buffer. So primary in, secondary on the right side.
Yeah.
Then that's going to feed the HT. And then after the HT unit, we're going to have a 4,000 litre store, which will feed the building at 85 degrees.
This head office that we retrofitted, no buffer vessels, 2 4-pipes, 1 HT unit.
First thing I'm going to say is, how does that work with peak load? When everyone opens up all the AHUs and all the RADs.
Well, but again, because you don't operate a building and open it up in that way.
So that goes back to the way buildings controls.
Yeah. So when you turn on the heating system, if you're turning your fresh air on at full volume, you've already made a mistake.
Okay.
So you've got to adjust your peak load first. Okay. You've got to control the building. You've got to make sure your heat goes where it's got to go. So if you go back to your 5-story building, I assume that way, you know, which floor, do they all have the same heating load? Do they all need heat and turn on at the same time? No, they don't, do they?
They probably don't know because heat rises and the upper floors are probably warmer.
Solar gain, those bits and pieces as it sits.
I see. Okay.
So by putting in a control valve per floor, you can actually put the heat where it wants it to go.
Would you put a buffer in though, just as a fail-safe? A thermal store, sorry.
Fail-safe for what?
Say a certain part of the system is out of action and you've lost a load of water around the system.
Depends on the selection design, you might have to put one in to get a minimum volume if you've actually then converted it over a 2-pipe system.
And that's the information that we need to look at before we go ahead with the project.
All about application.
So is that something that you would do? You'd say, listen, we're going to go to site, we're going to look at the volume, system volume, we'll work it all out, and we'll come up with a concept design.
But if you can adjust the volume through your heat pump,
yes,
then you're compensating the change of volume actually into your secondary. If you can't change your volume in your primary, but you can change it in your secondary, then that's where you've got to actually have the buffer vessel.
I see.
So product selection.
I see. Wow.
So you think how big a buffer vessel's got to be? You start talking.
When you say that, Phil, I'm like, keeping a thermal store at 85 degrees, that's a lot of energy.
For what?
That seems to be the norm with the design.
Even actually with a CHP, I'd actually put control valves and bypass the thermal store. Because you don't need it. It's a waste of energy. If you store water for that point,
for those that hope everyone knows what thermal store is. It's just a hot bath. It's just holds a volume of water.
It's a battery.
It's just
that's all it is. It's just a battery that's designed to hold energy. But a battery is always inefficient. Whatever battery you go from, you still lose energy as you charge it, versus when you discharge it.
So if there was a phase change thermal store where you charge it That's when it probably
But I would only use that when I wanted it. I wouldn't put it in there as part of the full-on
main
route.
concept.
Yeah,
You would
yeah.
do it as if we need the.
So that I would actually, if it has a phase change material, I'd be able to heat that up at night to reduce my peak loads.
Okay.
I'd actually then put a pump separate onto it to feed it into the system as another heat pump.
I see. Okay. So selection. So we're quite familiar with a lot of the chillers. Do you go as far as looking at the maintenance on chillers? So for example, we're going to sit down soon with a condenser company that make them down in Farnham. Big company, been doing it for like 50 years. And I can have a conversation off the record with them. And I really detest microchannel coils on chillers. And the answer I got was they're SHIT. They're great for efficiencies, but you get a leak in one of them and it's thousands of pounds because they can't be repaired. So I know it's because this is what consultants will always neglect because they're looking for the product, and I know you've suggested today that you've got to look obviously a lot longer than that with maintenance. Do you go that far, or there's only so far that you would or anyone would go? Whereas like as an engineer, straight away, I would always turn away a microchannel coil.
But what causes a problem with the microchannel coil? It's
a leak. No, if there's a leak on the coil.
If you start looking at the root cause of problems, most of the time, these issues with microbore comes down to poor water quality.
If I was to look at the only thing is that with an air-cooled chiller, it's refrigerant that's going through it. So it's just a leak because it's a failed part.
Yeah, but it does cost more to fix it. But you start looking at the failure rates of these. Well, do you design for the worst case scenario?
I know. What's pretty crazy is I've seen sites with chillers 7 years old, and it's almost cheaper to replace them.
Well, a whole chiller, it can be. But
because these coils, we unless you know the manufacturer, there's only a few manufacturers of alley coils, and you're buying through the manufacturers. They're not cheap, and you're losing chillers, and coils are on 10-week lead times. So whenever
that comes down to your point of duty standby.
That does cover that, yeah. It does cover that, but I know it's always tricky because you will always want to put in the most efficient product. But
exactly,
and it's like for me, like I don't know. And again, you didn't answer it when you said about your favorite chillers because there's so many different products out there. I love scroll chillers versus screw chillers because they're usually modular and they're usually in series, and you can take compressors out and replace them in the day. Whereas a screw chiller, you're looking at least a week, unless.
But you. I think what almost makes it different, you being on that side of the sense, you're seeing a lot of these, but probably not across the whole application numbers you're dealing with sites-wise. You start looking at how much the failure rate you've got versus actually that I might see from the opposite side, where actually I'm not in the job of replacing compressors over bits and pieces. I'll just see the failure rates across those. You don't get many failures on it.
Well,
so which one do you design for?
Again, the design is, but my thing with this is maintenance doesn't tend to get factored into a design.
In terms of the...
So even a screw chiller, for example, as an example, fantastic product, inverter screws, amazing at pot loads, not knocking anything because screw chillers are brilliant. And if anything, they're going to be around for a very long time, especially where turbo core's knocked off slightly now. But the issue is with them is if you don't have 100% standby, you're going to have to rebuild that screw compressor in 3-4 years when it's done a certain amount of run hours, and that is 2 to 3 days out of action.
Yep.
If you only have one of them on site with a HT unit, you've lost hot water and cooling, so you've lost both. So what I'm saying is you might specify a chiller which is perfect for this building, but if it is a screw chiller, do you look at, because I know a lot of consultants they don't look at, well, this chiller's going to be out of action potentially for 2 weeks, or do you actually go, well, we've got, are you implementing some maintenance, or it's a case of, well...
No, but that comes... Maintenance is a factor of monitoring. So by actually putting in, as you said earlier, the backnet Modbus cards, you actually start looking at the real parameters of how it's operating. You start looking at the data that comes out of it. You can start predicting when the parts are going to fail. So you can start ordering it 12 weeks in advance, 3 months in advance.
There's only a certain amount though, isn't there? So with a chiller, yeah, of course.
You start actually talking to the large manufacturer about all the points you can pick up through a Modbus and backnet. A lot of the brands now will actually offer you virtual maintenance because they can see so much more through that size.
Yeah, going forward, that's definitely the way it's going. And unfortunately, we use the word, not unfortunately, we use the word AI and smart thinking.
Yep.
I think the information, it's all there anyway.
Yeah,
They already have it. But you can never, if a star drive goes on a screw compressor, sometimes it is just one of those things.
Yeah.
R1234ZE works on very high compression, so the failure rate is higher, and you may not know because it's R1234ZE in a screw chiller, half the rebuild time. So you've got to rebuild it half the time that you would. So for example, it's being rebuilt every year and a half to 2 years if it's being used all the time as a heat pump.
That's where, as a heat pump, but if you start looking at the product selections you go from, and you start looking at the cooling only sort of situation you've got, so we would generally always try and put in, if there's space, N+1 on the heating side, but actually still have a cooling only unit because the efficiency is there.
You do.
Yeah.
So you like to still give a cooling only unit
because efficiencies.
I see.
So you've got to have the space anyway. That's almost a pre.
Is that because a full pipe chiller tends to have a slightly higher? It does have a slightly higher cooling load than heating load. So are you saying that you would match the full pipes for the heating load that you require, and then any surplus cooling that's needed
through
fantastic,
cooling only?
Nice.
So you're looking at the efficiencies. You're looking at everything actually in a different way.
Yeah.
Product selection is what it comes down to.
Wow. That's
if you haven't got the space, then you are stuck going for that way.
Of course.
But that's where the monitoring comes in. It's trying to engage as it sits. So trying to get things more looking. So we look at every 15 minutes, we'll look at the Modbus or BACnet table and pull all the data back. So you can start trying to be a bit more predictive before it's going to fail. But the risk when you've got, let's take 2 units and it is duty standby.
Yeah.
Or even if you designed actually on an 80% peak load for each one, you're only almost risking losing a single control panel or point unit on the opposite one to not give you that extra capacity with where it sits.
I'm with you.
So you sort of engage with the clients. How much more do you want to spend, or what's the restrictions? What's more important? Is it to have a spare part sitting on the site? If it does go, it's out of action for 2 days. Or do you actually want it oversized and that sort of stuff and go actually as it sits? Because you explain it to me is we're only talking the days when you're hitting 0 and below. And let's look at the time points. Well, actually, you're only down for 300 hours a year. You're at minus that one. And most of those are at night.
I'm with you.
So it's just that bit of a common sense application. You don't. Why design everything on -4 when actually the amount of hours you get is there? Right, that's one risk going down. Or actually, you've got this, and that matters. And if we don't have that, we've got to turn this. All right, okay. Actually, we can cope with a unit that's 80% of peak for an N+1.
I'm with you.
Because it copes for 95% of the year.
I'm with you. So it's going to work less hard.
Yes. Or ultimately be cheaper and obviously be more reliable.
So the next 5 years, where do you see the next 5 years? Do you see drastic changes? What you're doing is really impressive. I don't know anyone else that does this as a business or just in general. It's a different angle. Do you think this is going to become more popular? Do you see... Because without this, net zero can be a big waste of money if you're not applying things properly, and it does give bad
the
name.
cost between some of the clients we've got, what they've speculatively put forward for heat pump projects versus actually what we're already doing with clients, they're 10 times the value because it's how it's been designed, procured, operated.
Yes.
And that's almost where the problem is. That's why we're actually then getting busier, but we've almost got to come in and almost prove the badge first.
Yeah, I'm with you.
How it sits, and that's part of the reason why I
went
for it.
Trust, right?
Well, that's where that Engineer of the Year title really helps.
So how did you come? I know you applied
no
last
bribes
year.
involved.
No bribes.
No. It's
okay, that's good.
Yeah, all done off merit as it sits.
Fine. Well, were there like going for most awards? Did you know who you were competing with, or was it just you?
I didn't know the other finalists until they all got announced.
Okay, and were they similar role, different?
No,
completely different business.
Even so, last year I was a finalist. There was no one else that have. Again, as far as I know, hopefully someone might correct me wrong. I'm the first person to win it or even get to a finalist who's not got a degree.
Damn, good on you, man. Okay.
So that's generally that stands me out from the last 5 years it's been going on. Let alone where it sits.
So
in terms of the
it is
market.
good to show that you don't need a degree, but it's not discrediting those that have a degree. So kind of
different education.
It's completely different.
Yeah. How I've learned engineering is different for how they've been taught it by someone else. So I've learned it with my hands, with my eyes. They've been taught it through a book.
I'm with you. Oh wow. So has life changed for you since you had your CIBSE award? Like, are people throwing red carpets out for you as you go on the side?
if only. No, not quite.
It's a nice feather to have, though, really, especially for what you're doing.
It gives that kudos.
Yeah.
It
helps gain trust. So you're explaining this, and I'm sure there'll be some building owners or consultants that'll be like, yeah, I don't trust the guy. Well, the CIBSE element does help massively. And also you have got a lot of webinars. I've seen, as I said, I watched one last night for an hour on YouTube. I learned more in that hour than
Did you sleep well afterwards? Was it all right?
I did, yeah.
Quite relaxing. Like
a lot of bad dreams, but yeah, I slept all right. But I learned a lot in that just because it was a webinar and you're going through things and you're going through different system designs. But you've been there, you've done that, you wore the T-shirt. You've been the customer in the building, and you've also, now you're the other side where you're actually seeing, well, I know where things aren't being done right. So
the heat pump story for me has been going 12 years. Is you try and talk to other people that have done retrofit on a heat pump, and they might have one example. That might be 18 months old. They've not got 4 or 5 examples, and one of them is 10 years old.
Yeah, of course.
So, when you start looking at...
So you have got time. You've been doing it for a while, so you have got a bit of time on your side, really.
Yeah, so obviously, the first one, I was the client, and I drove it all through, understood it. So I was looking at it, understood technically.
You know what?
The
more you say you were the client, I actually think you'd be the most difficult. In a really positive way, you'd be really difficult. Were you difficult? You're the sort of client that I would have which we have, where very few on site you see it as a negative, but the reality is once you work it all out together and you understand things, you're the best client to have.
I was a very open client.
Yeah.
Very, very. If someone came with a suggestion, I would never say no because it's where it sits. Everything gets on that to get understood.
Yeah. But would you want to know the understanding first? Like, if something was put in front of you, you wouldn't just say yes. You'd say, okay, and then ask the questions after.
I never said yes to start off with. Yeah. So I always want to understand
Were you like you are now as a client? Or,
yes.
Okay, which is rare to have as a client these days, because
when I
a lot less clients are technical these days.
My first job as a client, I was a senior manager. I'd never actually been a manager before. I got the job on my technical ability, not having the experience as a manager.
I see.
Or being an FM going for that way. So I hit the ground running of knowing all the buildings straight away, because I designed the metering system and installed it in a few of them.
Yeah.
So I knew the buildings. So part of the interview process I had actually with one of the top people, he sat there and said, right, I'm trying to find someone that can understand the buildings very early doors and get the ground running. I said, I've designed a metering system in all your buildings. He said, what about the one that's going out the ground? I said, yeah, that one as well. So straight away, before I even started on site, I knew the buildings better than anyone else did on the site.
And there would have been no one else that could, because of the amount of metering you were doing.
Exactly. But I physically installed them. It's not just designed it, installed it. But
so you've installed them and you understand the importance of metering.
Yep.
Rather than... I think is there a new legislation out there now anyway, a CIBSE guide where you have to have metering on most devices now? Or is that...
so you've always had the Part L and TN39, which TN39 is quite old.
Is that what you have to have some kind of metering on the... But it's the bare minimum.
Yeah, and what it's connected to in the output. So again, you talk to this rear that I used to work for, the way they use their metering system, it's driven for 2 paths, 2 avenues of being used. One is energy management, it's quite crucial, but also it's how it's used for energy recovery at that site.
I see.
So they apportion the energy for air handlers, cooling and heating every 15 minutes based on demand per occupier.
I see.
So if an occupier asks for it to run slightly longer, they pay more straight away within that half an hour. Not across the end of the month. There's no apportionment, so they can actually track their energy every 15 minutes.
I'm with you.
So it makes them more accountable. So when you start talking to clients and occupiers over energy savings, what it means to them, and they consider data themselves and how it's moving further forward and go further, it's such a far easier to sell. So sometimes the first step in with a client is, let's look at your metering system. Yeah. Let's look at your data. How you energy recharging?
So going back to my building with 5 stories, or anyone, the answer to your question, if someone asks the simple question of how can I save energy, the sort of the answer to that is with data, with metering.
Yeah.
You're not going to do it without. And the answer isn't replace, okay, for net zero it is coming off gas, but it's not necessarily replace your inefficient product with something more efficient. It's more, let's use the data and see how things are working before you even get to that decision.
So I'll ask you, most, this is not heat pump related, what's MID? Do you know what MID is?
No.
Measurement Instrument Directive. So every meter that's used for energy recharging, billing those bits and pieces, should be MID approved. So this meter that's a full meter that is, electricity meters are. So if you're using that meter to charge an occupier off their energy usage, it should be MID approved. So if it's not, basically you can say I'm not paying my bill because it's not an accurate meter. So you start actually looking at that sort of side where that's almost actually an avenue for asset replacement. And when you're replacing it, you put a modern one in, you put a bit of communication between it, put a little gateway in, and all of a sudden then that essential meter replacement work now helps us out in so much more other ways. Not does it allow quicker billing, quicker money recovery, or bits and pieces. It also allows us actually to profile the buildings better.
Interesting. So just to pick up, so if I've got a project and we're replacing heat pumps or chillers, this could be sold as a package?
Yes, of course, yeah.
Is that how you do things? You look at something, we say, we'll sell this. I know you said it's not necessarily the cheapest as a retrofit, but before the project starts, it's something which could be sold as a package.
This should be done up front. So you don't have to depends what you're trying to go for, depends on the occupier.
Because the issue that I can see with this is if you're not involved with the design selection, this may work, but it also may cause problems.
Yeah. So
because you're saying, well, actually, you could make the statement to say this project could have been designed a lot more better based on the information that we've got.
Our value is before concept,
okay,
and up to stage 2, or actually when it's been completed to make it work. That bit in between, there's so many people out there that do a really good job of doing that.
Yeah.
And there's no point me coming into that market because it's a very competitive market. It's the upfront, it's in client engagement that might start off with an ESOS survey or ISO 50001 or trying to actually really engage with the pathway with the client around relationships and trust.
Okay.
That's where it starts. That's where our value comes into it and moving on from there.
So who uses you? So if you were to pitch out to people, who are using you? Building owners? Yeah. Are you working with consultants?
We are employed by some consultants for doing some work.
To do the stage 1, stage 2?
Or product identification. Concept. That's where they like to use us, is actually
to say, Phil, we trust you. You know, this is what the building we've got. Can you give us a product selection?
No. It's not opportunity selection. We might actually go in there first of all for some consultants and go, right, we need to do a survey of the building. Phil, can you come in and do it with us, using your experiences to help guide us through and actually make sure that we're looking at it from the right way, going for that way. Generally, end users, they're our key ones.
You like the end users?
Yeah. And then it's starting off, so it's not just when it gets down to a chiller replacement, feel we're stuck. It's early doors, it's pathways, collaboration. Might actually stem from a lighting job. We might be asked to look at that way, or a net zero pathway, or it can start from many, many avenues as it sits, or how we engage with them. But generally, it builds and builds and builds from there.
Contractors, do you work with contractors?
Yeah.
As in, would a contractor employ you to improve a design? Or to question a design?
Yeah. Either or. Again, there's not many words. I don't use the word no very often. If someone comes to me, it's because they actually want help.
Yeah.
Our smallest client is an outdoor adventure park up in Anglesey, where the whole introduction came from they are looking at putting some hot water cylinders in, open some pieces. I went out there, 1 day's rate plus travel time, and I saved them 15 grand. Nice. Almost overnight because their pathway going was the wrong way. So that's the smallest. The largest one was a national stadium. Second largest REIT, largest social media company, healthcare provider. We do all these people.
So what's driving you then? What you've got fire in your belly, which is amazing. Is it energy savings, or is it proving designs wrong, or is it just doing things
problem
right?
solving.
Problem solving.
Yeah.
So you like to solve the problem.
I've not met anyone else yet that's got my experiences to look at it in the same way.
Because of the both sides?
Yes.
Or the free sides. The free sides.
Well, you start putting metering there as well, and the whole concept of, we're used for setting up recharge systems, installing the meters, understanding it, progressing it further for an ISO design operation, ESOS surveys, ongoing monitoring, training, fan call maintenance. We do everything in between. If people actually want help, yes, we'll help you, but we're going to do it my way.
I'm with you. Amazing. So just one last thing, Phil. So for anyone like potentially watching that involved with projects, with net zero, consultancies, even manufacturers, I wouldn't say if you've got any advice for them, but would you ask them to expand their thinking, or what advice would you give them? Because everyone has a view on things and how they want to.
I see most of the mistakes made in the industry is where the client is being trusted in their question they're asking too much. So a client might go to a consultant, or it might be an FM provider, or it might go to whoever it is in a line and go, I need this. The client's not skilled enough to understand what they're asking for. So the first thing that actually the knowledgeable party should say is, have you thought about doing it this way?
Okay.
Not just taking that first point. So if someone says to a consultant, I need to get rid of my gas, is the first thing going, we'll put a heat pump in? Not necessarily. Can we get your gas lower first? Can we get this done first? Can we get that way? Or is it urgent? Do you have a time frame? What's it where it sits? It is what's actually the driver. So the client says, I need this. Why do you need that? So we can make sure we get to the right pathway in the right way.
I'm with you.
That's where I see it's the biggest mistakes being made in the industry.
Rather than having that, we need this, and then you become the salesman and just sell them anything.
Yeah.
You need to be asking the right questions.
Yeah.
Perfect. Right. That's a wrap.
Perfect.
That's an end for season 3. Thank you all for tuning in. Look out for season 4. See you soon.